Time for a bit of an update. We have been working pretty hard on getting the car back up and running after the problems we had at the first round of the South Island Endurance Racing Championship. Obviously, as you've already seen, if you've been following our episodes, we ended up with some reasonably serious damage to the engine as a result of an issue with our cooling system. And this is a real shame considering it was essentially a brand new engine. So we had a really tight window, 3 weeks to turn the car around and get it ready for the next round of racing. And it's not a lot of time, particularly when some of the parts we needed were outside of New Zealand. Given COVID-19 at the moment, getting parts shipped from around the world has become really problematic. Just a quick recap on the actual damage that occurred at the first round of the championship. And essentially we had an airlock in the cooling system which resulted in insufficient cooling around the cylinder head, particularly around number 1 cylinder. Basically it was like running the engine out on the racetrack with no coolant in it. So the head couldn't get rid of the heat. This resulted in the spark plug melting, and our suspicion here is that this became a source of pre-ignition on number 1 cylinder, which then resulted in the melting to the combustion chamber. On first look, it did seem that maybe the piston had got away with relatively limited damage. However, having our machinist check that out in a little bit more detail, it was apparent that the heat that had gone into that piston had actually shrunk the piston around about 2 to 3 thou. So really it wasn't going to be usable. Chances are as well, with the amount of heat that went into the ring pack, they'd probably lost their tension. So we were on the hunt for a replacement piston. It would have been ideal. However, getting one replacement piston out of the US in time was probably going to be an impossibility. So we went with what we could do, which was to source a set of CP pistons out of Australia. And fortunately, those actually ended up arriving out of Australia overnight, so we're really thankful for that. We also pulled a couple of favours with our engine machinist car aid up in Christchurch, and they put a few jobs aside for us and turned the job around really quickly. So that resulted in them basically honing the block. It doesn't need to be bored again. We're using the same first oversize 86.5mm piston. Really, there's no wear in the bores themselves, so just a very light hone to get that fresh hone pattern for the new rings to bed in. We also had them deck the surface of the block, so this takes out any imperfections, and given that we were showing signs that the head gasket was leaking, this is obviously an essential element. The other thing we needed to do was replace the cylinder head. Now, the head that we had probably could have been recovered, but we did manage to find a pair of second-hand P11 heads for about $500 each, so really probably wasn't worth it at that point persevering with the existing head. So we did take the opportunity, given that the P11 heads in a turbocharged race application are known or have questionable quality valves. We decided to take the opportunity to switch to an aftermarket valve as well, just giving ourselves the best chance of reliability with that head. The head was cleaned down, basically reconditioned, the valve sets were recut for our new valves, and those were all installed and the valve lash was set up. So basically we had a head that was ready to drop in. So as soon as those parts were back in the shop, I pieced the engine together. It felt like a Groundhog Day considering I'd only really just done this. So got the engine back together, back into the car, and then it was a case of addressing the issues that had arisen after our first test session. So we were having problems with the cooling system right from the get-go, and while there's a few potential issues that are at play here, one of the things we did want to do was get away from the factory mechanical water pump. Given that this is a SR20VE water pump, on an engine that is designed to rev to maybe 7,500 RPM, we're revving now to 9,000 RPM. It's quite possible with a lot of mechanical pumps that this can cause cavitation. So we wanted to get away from that, and we fitted a Davies Craig electric water pump. We're running this off the ECU Master PMU, and this allows us to control the duty cycle of the pump really accurately. How we're doing that is we're sending a CAN message from the Motec ECU to the ECU Master PMU with engine coolant temperature. I've then set up a two-dimensional table in the PMU, which is water pump duty cycle versus the engine coolant temperature. And we basically start it really slow, and then as the temperature comes up, we increase the duty cycle. And this way we can control the coolant temperature reasonably accurately. Another change or another problem we found last time was that we had a lot of data systems that were going to be installed on the car that would have actually highlighted to the driver the exact problem we were having, and hence prevented all of that damage from occurring. And the problem with this was that we simply didn't have time to complete the installation of all of the sensors onto the exhaust manifold. I'm talking here about individual cylinder exhaust gas temperature. Straight away, that would have highlighted the high exhaust gas temperature on number 1 cylinder, and we could have set up a driver warning in the Motec dash to tell the driver to get out of the throttle, something wasn't right. At the same time, we also had individual cylinder lambda sensors using 4-link CAN to lambda modules. These are transmitting data to the Motec C125 dash over CAN messages. And you might think that all of the cylinders are receiving the same amount of fuel and air, but that's actually not usually the case. There's normally some small discrepancies, and particularly as our specific power levels climb, these small discrepancies in lambda from cylinder to cylinder can be a problem. Again, at worst, this would have highlighted the fact that something was very wrong on our front cylinders. So we've now got all of those sensors fitted. Jimmy, our fabricator, welded those bosses onto the Synco exhaust manifold. We've got all of that configured and set up, gone through and set up warnings in the dash so that we're not going to end up having a repeat of that process. We also had a coolant pressure sensor fitted previously, but unfortunately, due to overlooking the position where we fitted it, I fitted it in a place that was nice and convenient, but overlooked at the time that we're also fitting it to the suction side of the mechanical water pump. So we didn't actually see any data because at high RPM, we're essentially seeing low pressure at that pump inlet, exactly what you'd expect. So we've relocated that, even though strictly speaking, that wasn't going to be necessary because we've now got rid of the mechanical pump anyway. We've got that pressure sensor fitted to the outlet from the cylinder head back to the radiator. So that should give us a full gamut of data to look at when we are back up and running on the dyno, making sure that we highlight any potential problems immediately and we can address them if something does come up. Since that unfortunate event at Teretonga Park Raceway, where we ended up also damaging the turbine wheel of our brand new Garrett GTX 3076 Gen 2 turbo, we managed to source a replacement turbo, and we also took the opportunity here to drop down from the 1.01 exhaust housing down to a 0.83, and we're hoping that this is going to give us a slight improvement in our boost response. We were finding, even with the sequential gearbox, that there are a couple of corners at Highlands Motorsport Park where we were essentially out of the boost range and we didn't want to shift down another gear. So we're hoping with a little bit more boost response, we should have something that's really usable with a nice wide power band. Remains to be seen if that's going to cost us any power in the top end. However, given that we haven't got this thing set up on kill at the moment, we aren't all in with the boost or the tune-up. We're expecting that even if we do give a little bit away in terms of top end power with that smaller exhaust housing, we can probably gain this back by running another half a PSI to 1 PSI of boost at that point. We'll just have to see once we get it back on the dyno how that actually pans out. Now, another thing that you may have noticed looking at the car behind me is it does look like a different car. I assure you it's not. This is the wonders of a wrap, and it really can be an effective way to change the complete look of the car. Given that this year we are running under our Earnest brand of workshop clothing, we decided that a fresh look was called for. We had wanted to get the car wrapped prior to round one, but the practicalities of losing a couple of days working on the car while the car was being wrapped just meant that we would have had no chance of getting to the racetrack. So we saved this, and we had Doctor B Signage come down from Auckland and wrap the car over a weekend, which was super convenient for us because it meant that we didn't actually lose any time working on the car. We've done a great job there with that eggshell colour and a really simple look that we think really stands out. So pretty excited to get this out of the workshop and see what it looks like ripping around on the racetrack. We've just finished up on the dyno, running in and basically giving the new engine a bit of a tune, and interestingly there's been a few takeaways from this. So First of all, let's talk about the electric water pump. We've fitted the Davies Craig electric water pump, and we're running this off the ECU Master PMU. And I wanted to experiment with using pulse width modulation to essentially control the water pump speed. This can be a little bit tricky because pulse width modulating the outputs on the power management unit does generate heat inside the PMU. So we need to be mindful of that, given that the pump is quite a high current draw, pulling up to around about 8 to 10 amps when it is at full power. We experimented and found that that just wasn't going to work. Basically, at certain duty cycles, it was overheating and shutting down that particular output to protect it. So it's something we knew that was a potential problem, and this is why a lot of power distribution modules don't actually offer the option of pulse width modulation, because the heat management is a problem. There's a couple of options we had available to us. One was we could add in a Motec dual half bridge controller, which is essentially designed for this very purpose. Basically, it's an external solid state relay that can be high frequency switched, and we knew that that would work, but we didn't have one here. I'd already wired the M150 ECU for that as a bit of future proofing for if and when we go to a TurboSmart electronic wastegate. So this allows a high current that the AMP superseal connector or pins or terminals on the M150 ECU can't pass through. So they're around about an 8 amp maximum current, and the TurboSmart electronic wastegate can draw up to 20 amps. So long story short, basically we had that facility. I'm trying to find simple solutions. We want to go to the track today, couldn't get the DHB here today. So instead, what we've done is actually changed the way the water pump is being controlled. So what we're doing is essentially replicating the way Davies Craig's controller works. So up until 50 degrees C, what we're doing is turning the pump on for 10 seconds and switching it off for 20. Between 50 and 70 degrees C, it's on for 10 seconds, then off for 10, and then above 70 degrees C, it's on 100%. On the dyno, straight away, running at full power, full speed, we found that essentially we've got an overcooling situation, which isn't a bad place to be. We've got another solution which we may consider if we still struggle to maintain engine temperature, given that at the moment out there we've got snow on the ground, snow on the hills. It is pretty cold. We've just had a weather system come through and a massive cold snap. So cooling to date shouldn't be an issue at Highlands anyway, but one of the things we could add in there is we could bring a thermostat back into the system with a couple of holes drilled through it just to allow water bypass through it. Anyway, that all seems to be playing the game at the moment. We've done some steady state running, we've done some full power tuning. We also had a little misfire that we needed to clean up. Can be a bit problematic getting spark plugs in the heat range that we want for this application with the correct fitment for the SR20. And we've got a plug that we've used a lot in the past, but it is non-resistive, and this has proven in a lot of instances to cause as many problems as it fixes. So we're running into some issues there. We've swapped to a BCP R7ES, which is a projected tip resistive plug. A couple of things I don't like about this plug. The projected tip is not ideal in high boost applications, and a heat range 7 it's possibly just a little bit too hot for the application we're running here, albeit we are on E85 and particularly on low boost, sort of 11 to 15 PSI, which is all we're going to be using for testing. Not expecting any issues with that, but we've got a set of HKS M40i plugs on order, so we'll run those for racing and see how we get on there. Anyway, everything at the moment seems to be playing the game. An interesting turn of events though that I wasn't expecting is we're making a lot more power this time around, and let's be honest, that's not a bad thing. Going over the changes we've made, first of all, we've got a turbocharger that is identical in terms of the wheel specifications. The compressor and turbine wheel is exactly the same. Still that GTX 3076R Gen 2 turbo. However, we have dropped to the 0.83 rear housing. Now, all things being equal, my expectation of this is that we would probably give away a little bit of top end power due to higher exhaust manifold back pressure. But gain some response. And it shows that it has gained some response. We're all in now by about 4,200 RPM, which is great. That's pretty much exactly what we're hoping for. But we're making more power, and I'm not talking a little here. Previously we were 385 to 390 horsepower on 10 to 11 PSI. We're now showing closer to about 440. So at the moment, I really don't have a lot of explanation for this. There have been some modifications to the combustion chamber shape, and we've gone to the aftermarket valves in the cylinder head, but that's not really enough to explain that jump in power. Last dyno run I've just done there was 565 wheel horsepower, and this is running 18 PSI. And previously, we weren't really seeing that sort of power even at 20 PSI, or we were probably there or thereabouts. The exact numbers now escape me, but fair to say we're making more power than we were, and we're making a little bit more power than I'd expect. So not a bad thing, but a little bit confusing given the sum of parts that we've got in here. However, it is what it is, and we're going to load up now and head to the track. There's a little bit of work to do putting the rest of the car back together. It is in sort of a few different pieces, so the cooling system's going back together, the ducting, the radiator, fans. We've got the guard, the bonnet, and the passenger side door still to go on. And I think we need to probably just have a quick look at the alignment as well, because we've had the left front strut out of it. All going well, we'll be at the track this afternoon, and we'll actually be able to hopefully prove that everything is doing what it should on the racetrack. And if that's good, it probably puts us in a pretty good position for this week's race, or this weekend's race at Ruapuna, so pray for us. We're back at Highlands. It is now Wednesday. We're leaving for Ruapuna and Christchurch tomorrow for our second round of racing, so this is really our last chance to test. Yesterday got cut short a little bit with an oil leak from the rocker cover, so we've replaced the aftermarket rocker cover bolts with some good old factory Nissan hardware, and so far that seems to be working. I've just been out and done probably about 10 or 12 laps. It's really cold still, so quite hard to get heat into the tyres. So there wasn't a lot of grip, and also learning basically what is a brand new car. It's got a lot more power than the V8, even though at the moment lap times are a little bit slower than my previous PB with the V8. That's just purely down to confidence in the car at the moment, and a little bit of a lack of mechanical grip due to the conditions. So not reading too much into that at the moment. Really today was more about shaking down the systems, making sure that the engine temperature stayed under control, oil temperature, etc. That all looks pretty good so far. Pushing as hard as I could for those laps. The engine coolant temperature sat around the high 70s to low 80s, so nothing really wrong with that, pretty happy. The oil temperature did come up to about 118. Not necessarily a problem, it's just a case of if I'd run for another 45 minutes, what would have happened? So we'll suit Ben up now and send him out so he's got a little bit of experience with it as well, and see what happens. We actually just had a diff temp warning come up as well, so that got up to about 135. So yeah, interesting to see what's going on there, but so far I'm pretty happy with how everything's going. It's looking pretty positive. Even tried boost setting 2, which takes us up to about 14 PSI, and yeah, fair to say that the car is definitely a rocket ship, so pretty exciting.
If you like that video, make sure you give it a thumbs up, and if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.